Okay, today is called combinations and probability. Isn't this the third day we've done combinations? Yup, it is. But it's just because they get harder and harder and harder. What you learned yesterday was about when to use a regular C, and I'll give you one and see if you can write this. Something C something, okay? There are about 30 of you. Let's say I'm gonna pick 5 of you to be at my basketball team, okay? Now, in reality, I might pick the best basketball players. Would that be random then? No, that'd throw everything off. Okay, so if I don't do it that way, if I pick up randomly, just pick 5 of you to be the team, okay? How many different teams could I make? Make me a C question. That was like day 1, and it should be easy for you. Say there's 30 of you. Frankly, I'm not going to count. This takes too long. Okay, so if there's 30 of you and I get to choose 5, did you just write 30C5? What's the difference between that and a P? The order patterns when you use a P. And if we're picking our basketball team, the order does not matter. Now, if I specifically assign spots, like you're the boss of the team, you're going to be in second in charge, you're going to be third in charge, or even if we assigned positions, like you're going to be the center, you're going to be a forward, you're going to be a forward, you're going to be a guard, that would all of a sudden mean the order might matter. But the way I said it before, order didn't matter. All right, when would you ever split it up into 2 C's being multiplied? That's when you take little subsets. Like in this classroom, there are 30 of you, and let's say it's boys and girls, and let's say it's 20 boys and 10 girls in this room. Do you see how I've started to divide this into 2 separate C's? And let's say I was going to pick a committee and I wanted it to have 2 boys and 2 girls on it. Would you finish this one? How many different committees could I have? If there's 30 of you, and if 20 of you are boys and 10 of you are girls, how many different committees could I get that have 2 of each? See how it's getting more complicated? But don't overthink this. I already started it for you. You just need 2 numbers. It's not that hard. So if you're going to pick 2 of each, you put 20C2 and 10C2. Raise your hand if you had that one right. Okay, now I'm going to not set it up quite so much for you and try another one like that. Okay. Let's say it's, let's say, here's a bunch of tests. Okay, and then sitting in the room, I have about 30 tests from last hour. They just took those tests. Okay, and let's say, out of those 30, there's 10 of them that I know are like for sure going to be A's. Okay. Then, if I grab 2 tests out, what's the probability that I get one of them that's an A and one of them that's not? So I'm going to say the details again. And hint, don't get all lost in this. It's just CC. And as soon as I said probability, it was CC divided by C. Now again, there were 30 total tests. Where do you put your totals? On the bottom. And I was going to pick out 2 of these tests. That's the total I'm picking out. So you get how it's 30C2. That make sense? Okay, now, how do you do the top part? I'm going to say it again. There was about 10 of them, of the 30 tests, that are going to get A's. Then that just defined your 2 things. People that got A's and people that did not get an A. See if you can finish this puppy off. My question was, out of the 2 random ones that I pick out, what's the probability of getting one with an A and one that does not get an A? Okay, it's kind of like a little puzzle, because remember that this plus this equals this? Does that make sense? You get that those have to add up to 30? And which of those numbers did I tell you? Did I tell you the A's or the not A's? A's. How many A's did I say there was going to be? 10. And therefore you know the not A's. 20. And then these green triangles have to add up to 2. So, what did I say? I remember what you want goes on top. What did I want to get? One with an A, one not an A. There's your answer. 10C1 times 20C1, all over 30, choose 2. Now, just to make sure you know how to put this in the calculator, because that is part of this test, it's like get me the decimal probability. Decimal probabilities are always between 0 and 1, and you pretty much never have a 1 and pretty much never have a 0. But you'd never get an answer like 1.2, because that's more than 100% chance, right? Okay, would you please use your calculator and see if you know how to put this in. If you need to borrow a calculator from me, do that at this time. I'll pause while we do that. So, all said and done, these are separate little things, but they're getting multiplied in there, right? And 10C1 is a really easy answer. In fact, some of these you might just trust yourself to be able to do. Now, I don't know, you may not want to trust yourself, because I know it's going to be scary, but if I have 10 things, and I want sets of 1 of them, what do you think that answer is? 10. 10 choose 1 is 10, okay? How about 20 choose 1? I have 20 things, and I'm going to take them one at a time. How many different ways can I do that? 20. So could you have done the top in your head, 10 times 20? Yeah, you could have. 10 times 20 is what? 200. There's 200 different ways that could happen. I might get this kid's test and that kid's test, or this kid's test and that kid's test, or anyway, there's a lot of ways that could happen. Way more than you would think. It's counterintuitive, I know. All right, so the bottom part, 30 choose 2. Now that one's way tougher. If you had to do it on a test, do you remember it'd be 30 factorial on top, and then you always do the 2 subtracted, which would be 28 factorial on the bottom, and one of them, C, there's an extra 2 right there. That's how you'd do it if you had to do it in your head. So let's just make an imaginary scenario where I really need to get this answer, and I don't want to have to walk all the way to my basement where my calculator is. I'm just too lazy to get up. So I'm going to say it's 30 times 29 times 28, dot, 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 dot. And the 28 on will cancel. See, the 28 factorials will cancel. So it's really 30 times 29 divided by 2 times 1. So 30 times 29 over 2. 2 times 1 is just 2, right? And then I can do the 30 is really 15 times 2. Cancel the 2's off. And it's really 15 times 29. All right. So what is 15 times 29? That I'm going to have to go to plain old-fashioned like this. Let's see if I can just finish it off right. Can you tell me what it is? Go ahead. 435? Thank you. It'll save us some time. Do you get, I can see that this probability is about, it's a little less than half, so a little less than 50%. What was it exactly? 40-something? 45-ish percent? 46-ish percent? I'm not being exact here, about 46%? About? Okay, good. All right. That's the main thing for today. Now, I talked you through that one totally. This one, I'm not going to talk you through all the way. You got to make a CC over the C. These are complicated, and you really have to think them through. Do you get our district has a gajillion smartboards? Almost every room has a smartboard in it. Mine happens to have 2 in it. One of the rare ones has got that. And that was special because we got a special grant to do that. So anyway, you don't get your smartboards all on the same day. They just give big delivery of smartboards, and then you install a bunch, okay? Do you get when you have a district like ours and 1,000 smartboards, let's say, that a few of the 1,000 probably arrived not working? I don't think about that too much, but you know, you get defective ones. They come out of the factory, they think they're going to work, and then there's just something didn't work right, and it doesn't work. That's called a defective machine. All right, so here's my scenario that I need you to set up. In the end, it's just a C over C. There's 1,000 smartboards that get delivered to our school, and they're sitting in a warehouse. They can't install them all on the same day, okay? But 1,000 of them get delivered. Our best estimate is that out of these smartboards, 2 will be defective. We don't know which ones, but from past experience, let's say 10% of the smartboards would have been 100 smartboards not working. That's not likely. 1% of the smartboards being defective would have been 10. So this is way better than 1% defective rate. As in 90, it's like a 98% working rate. But still means you got 2 that are going to be defective. That's just part of the deal. All right, that's 2 out of the 1,000. So now here comes the question. If we go install 25 smart boards, the rest of them are staying in the warehouse, 25 are installed today, what's the probability we get 1 defective one out of that group? It's C over C. Start with your totals. It really helps. You think about how many total smart boards do I have? How many am I actually choosing to pull out of the group? Start with that bottom C. And then think of it as a little puzzle. I'm going to pause while you give that a try. All right, I know these are tough. So without waiting too long here, I'm going to help you with this one and see if you did it right. Dice of Destiny are going to get me to call on a few kids. This is row 6, person 4. 1, 2, 3, 4. That's you in the back. Tell me something about the totals. That's the easiest thing. Yup. We did not just pull out 2 smart boards. That is the most common mistake, so don't feel bad. Thank you. Take a look at the question again and figure out how many smart boards got pulled out in this problem. We took 1,000 of them that were in the warehouse. We know out of that, there's some of those are defective. Did we go through and just pull out the defective ones? Is that what the question was? No. How many did we pull out and install? So it's 1,000C25. That's what it's out of. Now that you know that, go back and adjust the top. Remember, this is a little puzzle. This plus this has to add up to 1,000. And what are these 2 groups? Is it like boys and girls? No. What are the 2 groups we divided our smart boards into? Working and not. Defective and not. I'm going to call it defective and not defective. Or you could say working and not working. Whichever, however you want to do it. I'm going to use the word defective because that's what I used in the problem. Okay, now that you understand that this adds up to 1,000, how many defective ones are there? 2 defective ones. Some of you are like, you said 1. No, I'm going to pick 1 out of the 2 that were possible. I'm going to pick 1 of them. This is my scenario that I got 1 defective out of the 2 that are there. It says right here that there was 2 defective. So again, one thing at a time. This 2 and this blank should add up to 1,000. So how many not defective ones are there? 998. Okay, awesome. Then there's only one little piece of the little puzzle left. This part plus this part has to equal this part. Ooh, I did it with triangles. So this has to be 24. Now think about it. We got 24 not defective, as in working, smart boards. 1 that was defective. 25 total. Is making sense to you? I know these are tough because at least half of you got it wrong that first try. So, you know, it's hard. All right, let's try another one. This one's actually in the smart board. Right here, it's the same idea as what we just did. Remember, it's a CC over C. In fact, this one might be a CCC over C. Because it isn't just divided up into boys and girls, or defective and not defective. This one's like hearts, spades, and all the other cards. Now, you guys may remember that I said when we do problems like this on a test, I promise I'll put up this thing on the board. So it's not on the screen for people at home, but this is a list of all of the different cards that are in a deck. So if you're like, what are you talking about, these clubs? I've even got them labeled over here. This is what a club is. This is what a spade is. And then there's also the 10 that are called hearts and diamonds. Remember me saying to start with what was possible? So how many cards could you possibly draw from the big group? 52. How many are we going to actually deal out to people? 5. 52C5. Then remember that the other ones will have to add up to 52. This and this and this have to add up to 52. And what are my little subgroups? Boys and girls? No. Hearts and what else? Heart, spade, and what do we say for the other ones? It's 2 smart ways you can do it. You could just say the names of the other things, or you could say not hearts and spades. See what I mean? I'm going to do it that way just to get used to that idea. It's either hearts, spades, or not hearts or spades. Okay, so then, if you know how cards work, you'd know there's 13 hearts in the deck, and there's 13 spades in the deck. And then the ones that aren't those two, well, it's just a logic question. That and that and that have to add up to 52. So therefore, that must be 26. Raise your hand if you had those right. Awesome. And then the last thing is, how many hearts did I... Remember, this is what you want. What you want goes on top. What I wanted to get was 3 hearts. 3. And 1 spade. 1. And 1 card that's not a heart or a spade. 1. Do these actually all add up now? 3 and 1 and 1 and 5. Yeah, 3, 4, 5 adds up to 5. Yay! I did it. That's it. Okay. Here's another one that freaks people out sometimes. See if you can handle it. It's a card question. I'm adding this one because it's a good question, because it leaves off one little piece of information and you have to be logical about this. Do you get trips is a pretty good hand? Okay, that means you get 3 jacks. That's called trips. Okay, I got triple. All right, I got 3 jacks. So, what's the probability, given that there's 52 cards in the deck, and I'm going to deal you out 5 cards. That's a typical poker hand. You get 5 cards. What's the probability that you get 3 jacks? And you're like, well, wait a minute. You said we were going to deal 5 cards. Yup. Probability you're going to get 3 jacks. Just clarify, not 4 jacks. 4 jacks isn't, I mean, I know in the real world it's actually better, but I am talking about a hand with trips in it. 3 jacks. CC over C. I'm pausing for a second to see if you can figure it out. C. Okay. All right, so 52C5 is what it's out of, because there's 52 cards and we're picking out 5 of them. What are the little groups that are on the top? Mr. BH. All right, jacks. And what? And not jacks. Good. And if you just do the jacks, do you get how people would go, there's 4 of them and I want 3, and then they stop the question? And then they lose because, why? It doesn't balance. This is supposed to be this plus this. And so let's finish it. What did you get for not jacks? 48. And how many of those do we want? 2. If you forget that, you've lost a number. The other time I said you didn't really need this part, that's because it always equaled 1. That does not equal 1. That's a really big number of things that are not jacks. What's really happening here is this is all the different ways you could get the jacks. Do you get how you might get the jack of diamonds, but you might not? You might get the jack of hearts, but you might not. And so there's all these different combinations of jacks. This is all the other cards, and there's tons of them. You're going to get 2 of those other cards, and they could be all different combinations of cards. Why are we not using P, by the way? Because order doesn't matter in this question. We didn't say you would get jack, jack, something else that's not a jack, and then a jack. You know what I mean? We didn't say that. If we did, then the order would matter. All right. So that's a typical question for today, and that's really all there is to it. So let's just do one here where I don't tell you anything. See if you can get the marble question here. I'm pausing while you give that a shot. So if you were having trouble getting started on this question, which part have I suggested to start with? The bottom, the denominator. And that's a C down there. And then you think to yourself, okay, this is where the totals go. what it's out of. All the things that were possible. Well, how many marbles were there? 15. And how many of them total am I going to take? 6. There's the totals. Then you just think about what are the groups this time? Is it like boys and girls? No. Is it like defective smartboards and not defective smartboards? No. It's red, blue, and there's another one for the yellow. Then, how many red ones are even possible? And how many do I want to get? This is what I want, right? 4. And then, how many blue ones are even possible? 3. How many am I wanting to get? 2. And then lastly, how many yellow ones are possible? And how many do I want to get then? And now, sometimes that's a 1, and then you can't just like say you don't need that one. This time it's a 0, and you really didn't need that one. Why? Because that's equal to 1. But it's good to have it, because then you can see them all add up. 8 and 3 and 4 add up to 15. And I'll do it in blue. 4 and 2 and 0 add up to 6. There you go. Okay. So now I get to show you another kind of problem that's a classic dilemma in probability, and it's going to blow your mind. You're going to think you know the answer. You don't know the answer. It's a very counterintuitive kind of thing. All right. So I'm going to do this Monty Hall dilemma after the video is done here. I'm going to stop the video at this point because this is more like an enrichment activity.